And this is the so we have for the FM we have got card data where 728 records and 7 featured variable are available. So after loading and getting the data, we have inspected it properly. So we have found the data is clean. There is no null and duplicate entries. Data is very clean properly. So after that, we have run the exploratory data analysis for the 7 features variable. So we have found that for the 6 features, the data has been distributed and structured properly. But for the 7 target variable, which is our target variable, the data is skewed toward unacceptable classified data set, which is almost 1200 times. So after that, we have run bivariate analysis for the 6 features variable with car acceptability. We have found here 2 seats and low safety data is classified as unacceptable, and for price very high and high maintenance cost and very high maintenance and price cost are heavily classified as unacceptable, and data are heavily concentrated on low and medium price and maintenance cost. So after that, we have run correlation heat map where we have found the price, maintenance, and doors. Those are correlated with zero each other. So the features are partly perfectly independent. Our data set are orthogonal. That means most of our features are independent, perfectly independent. So we have found here the safety features are positively highest correlated with should buy and followed by the seats features. So these are the two significant factors for the card acceptability. And on the other hand, the price and maintenance are inversely correlated with the should buy features. So after that, we have run multivariate analysis with price and maintenance with on by decision. So we have also found here that high and very high price and maintenance cost has inversely correlated with classified with buying decision, and the buying decisions are heavily concentrated on low and medium price and maintenance cost. So after that, we have run also safety analysis with buying decision. Here we have found that though for medium feature, we are getting some good and acceptable rate, but the highest acceptable, the highest very good acceptable rate is for high safety. So it is the main influencer factor for buying decision.
Myself Soundarya. Here now we will see like how we have done data pre-processing and encoding. Machine learning models usually don't understand if the data is not in a numerical input format. So here we could able to see the data which is not in a numerical format. So we could able to see the records are in a sequential order for all of them, and we thought like we can't able to do the one hot encoding. Instead, we wanted to do with the ordinal or label encoding. So we ranked each of the data with the based on their sequential order, and now we could able to see the output of output after encoding. Um, so next, like we have almost like 1,728 records, and out of that we thought to get like 80% of data to train the model. So from the data set, like we have got 1,382 records, and here we could able to see the first category, which is unacceptable, having 968 records. So it might predict every time, like the model will predict the most of the data will be unacceptable. So that would we think like that won't be fair one. So we wanted to do oversampling. So we have done oversampling using synthetic minority oversampling technique. So based on that, like we have taken 80% of record to train the data set and 20% to test. So we have taken like 3,872 records, and like now we could see all of the categories having 968 records. So after this, like we want to perform these 5 algorithms. So we have used Genie, entropy tree, random forest, gradient boosting, and Mars. So uh, based on the data set which we have to for training, so we have trained using the data set and evaluated, and here we could able to see the performance metric. Here Genie is having the highest accuracy of 97.4%, and AUC is like almost 100% for gradient boosting and random forest. So all models like are performing very good, and it's likely to be overfitting. So to generalize this, like we have done some regularization for all of the algorithms, and later after generalizing and training, we could able to see the performance metrics. So for all the algorithms, and here the random forest accuracy of random forest is highest, which is like 94.5%, and followed by the other algorithms, and AUC is like 99.5%, and precision is like 95.1%, which sounds fair, and we think now like it would work properly. And um, after some analysis, we could able to see the visualization where the random forest has is looks as a best model, followed by the other algorithms. So the best performing model is the random forest. Now Jayanta will continue from here. Thank you.
Welcome back, myself Jayanta. So previously you have already seen random forest is the winner. Now we will try to getting the best out of it, this algorithm, by doing the hyperparameter tunings. So what is hyperparameter? Hyperparameters are the estimator or some kind of parameter which is used for a algorithm to predict our data. So here for random forest there are mainly 4 different algorithms: n estimator, max depth, mean sample split, and like creation, or this is actually for calculating the loss. So this one we have got separate combination of it, and by using grid search CB algorithm, we will what we will do, we will take different kind of combination of those, and based on accuracy we'll find out the best combination. So for random forest we find out this is the best combination which can give us the best result, that is entropy max depth 15 split 2 n estimator 200. Now let's understand what is it giving after the final before and after. So before tuning we saw the accuracy was 94, and after tuning it became 97. And if we see the final confusion matrix and we saw the diagonal part, so here we can see it's correctly classifying vast majority of unacceptable and acceptable classes, and crucially in the precision of good and very good, so the substantial gain, meaning we are far less likely miss out on high value deal. So this is a good model. So now understand the model. So if we try to understand the model correctly, so by plotting this model we can see the root node immediately split based on safety and capacity. That confirms that before the model even care about the pricing and maintenance cost, is essentially asks, is it safe, or can it fit people? Now if we see the feature importance, we can see safety is the most important feature to predict the decision. Now extracting the classification rule in a most human readable way. So if we see the top rule, that is a deal breaker. If the car doesn't have 3 seats, it's off or it is unacceptable. Now the second, the low safety rejection. So if we see 2, 5 and 6 here, we will see if the safety is less, or even the car has 4 plus seat, if safety is low it is unacceptable. Then the acceptable, this is actually the standard choice. It will be asked, and it will be acceptable is the minimum requirements and capacity maintaining a reasonable price. Now the high value, those are good rating which passed all the standard checks and ongoing maintenance and low cost. So this is the standard logic, like capacity must have more than 2 seats, safety must not have low safety and low maintenance cost. Upgrade a car from acceptable to good. Thank you.